Okay, we're going to look at the absolute value function. We're going to learn how to graph it using a table, and then we'll apply the transformations we learned into a table and see what happens with the graph. Alright, so we're going to look at f of x equals the absolute value x. That's the parent function for absolute value. We're going to choose some x values. So we're going to choose some negatives on the left side of 0 and some positives on the right side of 0 because we know absolute value is a V shape with the origin is where the tip of the V is. So what we're going to do is we're going to put our x value into the parent function. Substitute negative 2 into x. So the absolute value of negative 2 is positive 2. Absolute value of negative 1 is positive 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Alright, then once we got our table filled, we're going to go ahead and graph that. So negative 2, 2. There, negative 1, 1. 0, 0, positive 1, 1, positive 2, 2. And you see the V shape starts to form. So we'll just continue that pattern and we have our absolute value function. Alright, so we graphed it. We're going to identify the domain and range, which we know that it is negative infinity to infinity. Identify the range for this function, which is 0, infinity. Alright. We want to find the x-intercept. In this case, the x-intercept is where the function hits the x-axis or intersects the x-axis. So in this case, it's going to be at the point 0, 0. Find the y-intercept. It'll be also at 0, 0. Alright, now we're going to identify a reasonable domain for the function in figure 1. Alright, so reasonable domain, well, as you can see, it's the x span of the x values. So it's going to be from negative 4 all the way to positive 4. Alright, including negative 4. So we'll have brackets, negative 4, comma, positive 4, open parentheses. Alright, identify a reasonable range. So bottom to top, bottommost number is negative 2 to the highest most number, which is positive 4, including both negative 2 and negative 4. Negative 2, comma, positive 4. Bracket. Where is the x-intercept? Is there an x-intercept? If yes, what is it? Alright, well in this one it has two x-intercepts. So, yes there is. And we have one at 0, 0. And we have one at 4, 0. Alright, remember these are ordered pair points, so they're not intervals. What is the y-intercept? The y-intercept would be at the origin as well, 0, 0. And that is the y-intercept, where it intersects the y-axis. Alright, how does changing the number in front of the x affect the graph? Well, that's going to give it a vertical stretch or compression. How does adding, subtracting a number inside the x affect the graph? Okay, it'll translate left or right. How does adding, subtracting a number outside of the absolute value affect the graph? Well, it's going to translate it up or down. Alright, now compare the graphs. Y equals the absolute value of x, that's our parent function, and y equals the absolute value of x minus 2 plus 4. What is different and what is the same about the two graphs? Alright, well, the first graph is the parent function. Alright, so what is different about it? Well, one of them is going to move. Let's put different. Okay, one of them is going to move right 2 units. Alright, and up 4 units. Alright, what's the same about them? Both have a V shape and open upwards. Alright, here we're going to graph a little bit. Alright, so describe the transformation. So here we have y equals 3 times the absolute value of x. So this is going to be a vertical stretch. Alright, create a table, x, y. Again, some values, -2, -1, 0, 1, 2. Alright, so this is what we're going to do. Substitute the -2 into the absolute value of 3x. So y equals 3 times the absolute value of -2. Absolute value of -2 is +2, which gives me 6. Alright, so that's what we're going to be doing there. Pen keeps changing. Alright, so +6. Alright, so -1 is +1. That's going to give us 1 times 3 is 3. Absolute value of 0 is 0. That's still going to be 0. 3 times 0 is 0. Absolute value of 1 is 1. Times 3 is 3. Absolute value of 2 is 2. Times 3 is 6 as well. So, a little bit bigger numbers. So, -2 up 6. 1, 2, 3, 4, 5, 6. Kind of hard to see. -1, 1, 2, 3, 0, over 1, 1, 2, 3, over 2, up 6. And as you can see, there's our absolute value. And it looks like it's been stretched. It's more narrow. Domain. Domain is still -infinity to infinity. All real numbers. Range didn't change as well. Still the same. 0 to infinity. Alright, so f of x equals 1/2 of the absolute value of x. So it's outside the parentheses. This is going to be a vertical compression. Alright, again, x, y table. -2, -1, 0, 1, and 2. So absolute value of -2 is +2. 2 times 1/2 is 1. Is 1. 1 times 1/2 is 1/2. 0, that's still going to be 0. Again, 1/2 times 1 is 1/2. And then absolute value of 2 is 2. 2 times 1/2 is 1. So much shorter. -2, 1, 1.5, 0, half, and 1. So as you can see, it got much wider. Alright, so vertical compression's been squashed. Alright, domain, it's the same as above. -infinity to infinity. Our range is 0 to infinity. Alright, y equals the absolute value of x minus 1. So it's inside the absolute value thing. It says negative, so we know it's going to move right 1 unit. Alright, let's see that in our table. X, Y, -2, -1, 0, 1, and 2. Alright, so the -2 minus 1 is -3. The absolute value of -3 is 3. -1 minus 1 is -2. The absolute value of -2 is 2. 0 minus 1 is -1. Absolute value of -1 is 1. 1 minus 1 is 0. Absolute value is 0. And then 2 minus 1 is 1. Absolute value of 1 is 1. Okay, again, all I'm doing is plugging into the x value here. Alright, so let's plot it. -2, 3, 1, 2, 1, 2, 3. Plot there. -1, 2. Right there. 0, 1. Up 1 there, then 1, 0. There it is, and then 2, 1. 2, 1. Alright, and as you can see, it just shifted over 1 square. Alright, last one. Alright, so absolute value of x and then plus 2. Okay, plus 2 is outside the bars, the same thing as being like outside the parentheses. So now we know this is going to be a translation up 2 units. I'm going to fix this one. Oops. I don't know how that happened. There we go. Alright, so I just want my pen. Okay, so this one's a translation as well. Okay, right 1 unit. Alright, make our table. -2, -1, 0, 1, and 2. Alright, so the absolute value of -2 is 2. 2 plus 2 is 4. Absolute value of -1 is 1. 1 plus 2 is 3. Absolute value is 0. 0 plus 2 is 2. It should be 3. Absolute value of 1 plus 2 is 3 again. And then absolute value of 2 is 2 plus 2 is 4. I'm going to graph those. -2, 1, 2, 3, 4. -1, 3. 1, 2, 3. There's 0, 1, 2. 1 and 3. 1, 2, and 3. And then 2 and 4. And there is our function. And it moved up 2 units from the origin. Alright. Oh, domain range. So the domain range for number 3, still -infinity to infinity, all real numbers. The range didn't change as well. 0 to infinity. Okay. Parentheses. Alright, domain here. Domain still -infinity to infinity, all real numbers. Come on, pen. And then the range did change this time. This time your range bottom touch starts at +2 to infinity.